Today's daily code problem of the day is valid Sudoku number 36. For this problem, we're going to determine if a 9 by 9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. So each row must contain the digits 1 through 9 without repetition. Each column must contain the digits 1 through 9 without repetition. And each of the 9 3 by 3 subboxes of the grid must contain the digits 1 through 9 without repetition. So the Sudoku board is going to be partially filled, but it does not have to be solvable. And we only need to check the filled cells. So if we look here at example 1, 5, 3, 6, 9, 8, 1, 9, 5, 7, right? So we are only checking these filled numbers, and we only have to make sure that they only appear once per column, once per row, and once per 3 by 3 grid. This is how our input's going to look. So we can see that the period, and I don't know why they have it with the double quotes, but they are characters. So we can say, okay, a period means that's blank, and then otherwise it'll have a number. We could also check down here. No matter what, it's going to be 1 through 9 or a period, so we don't have to worry about something like a 10 or 12 showing up. So let's go ahead and jump into solving this problem. First thing we're going to do is identify a Boolean array for our rows, columns, and each 3 by 3 grid. So we'll have a Boolean 2D array called rows, which is a new integer array. And then each of these are going to be, there's 9 rows, and there's 9 digits that can appear in these rows. So it's going to be a 9 by 9 2D array. We'll do the exact same thing for our columns and our 3 by 3 grid. So we'll have 2 more of these, one for columns and one for boxes. So what we're going to do is we're going to do a single loop over our 9 by 9 grid. And each time we see a number, so for example, we see 5 here, we'll add 5 to, this is 0, 0, so rows of 0 of 5 will be updated to true. Sorry, these are Boolean. So rows of 0 of 5 will be updated to true, but it's 0 index, so it'll be rows of 0 of 4 will be updated to true. Moving on, okay, so now we are in column 1, but we're still in row 0. So we're going to have rows 0 of 2 will be true. Columns of 1 of 2 will be true. So on and so forth. And then we'll do the same thing for our boxes. I'll show you how to calculate the box positions as well. Now, like I said, we're going to do a single pass over the full 9 by 9 grid. So we're going to have a 4 integer I is equal to 0 as long as I is less than our board dot length. I can increment. And then we're also going to have the same thing for j. So for each integer j is equal to 0 as long as j is less than board of I dot length j plus plus. And within these two loops, we're first going to identify the number that we're looking at. And the number that we're going to be looking at can be a period, because that's what it is when it's blank. So we're going to store it kind of as a char first. So first we'll check if it's a period. If board of I of j is equal to a period, we don't want to continue. So we'll say as long as it's not equal to a period, we will continue. And then we're going to have it stored as an integer. So we're going to have integer temp is going to be equal to board of I of j minus the character 1. Now the reason we're doing minus the character 1 is because we're storing these as 0 indexed integers. And this basically says turn this into an integer and convert it to its decimal value, right? So if we subtracted the character 0, we would get their actual position. However, for example, if we were to get the number 9, it would go out of bounds. It's 0 indexed. So this will turn a 9 into an 8 and a 1 into a 0. We're also going to calculate the box index. So this box index will calculate the position of a number within a 3 by 3 grid. So we're going to, or which grid specifically we are in. So it's going to be I divided by 3 times 3 plus j divided by 3. So by using this formula here, we are able to calculate which grid we are in. And we need to know each position of the grid, just which grid specifically we are in, and we can use that to determine if we've already seen a number within that grid or not. Now moving on, we've already determined that the number we're looking at is not a period. All we have to do now is check if it has already shown up. So because we are storing these as booleans, we can simply say if rows of, and then our rows is the I, so rows of I of our temporary number is true, then we'll return false. And we'll do the same thing for columns. So if columns of j, because our j is what increments the columns, so if columns of j of our temporary number is true, we'll return false. And then same thing for our boxes. So if boxes of our box index is true for our temp number, then we're going to return false. And that is it for that checking if things are false. If none of those are true, and that means we have a valid position or a valid Sudoku board so far, we need to upgrade each of these to be true. So rows of I of temp needs to be equal to true. Columns of j of temp needs to be true. And boxes of box index of temp needs to be equal to true. And that's it. So if we're able to break out of this kind of single pass over our 9x9 grid, that means we never found any duplicates in the rows, columns, or box indexes. So we can return true down here. So if we run this, passes our test cases, and if we submit it, that is our solution. So thank you, and follow for more daily LeetCode solutions.